Okay, we're in section 6, and this is going to be the assignment on linear inequality. Again, it's important. I realize for a lot of students, lecture really doesn't give them much, all right? They're not prepared for the lecture. What I mean by that, sitting through something, someone talking over something in an abstract way. It's where the examples, we're hoping that when we do the examples, that much of the information we talk about in lecture becomes more concrete. My goal here, though, is to get you guys used to hearing lecture material. It's going to be short, though. It's not going to be long. What are we going to do? We're going to talk through this material over here, properties of inequalities. And I'll outline what Essex is going to steer you towards, all right? That's what we're doing. We're trying to steer you towards what Essex wants you to learn, all right? When I say that, the math department at Essex, and I've been teaching her a long time, so I know what they want you to do. And I got to be honest with you, what they really want to do is, although I believe property 1 is probably the most important property, I just never see them talk about it. All right. I never see them talk about property number 2 either. I see them talk about property 3 and 4, though, a lot. All right. I'm going to concentrate on that. We'll go back to the whiteboard later. All right. The other thing I'm going to concentrate on is notation. How to read an inequality, how to represent it graphically, how to use set builder, and how to use interval notation. You should notice in the notes, though, I have little embedded videos for those students that want to watch those embedded videos. You don't have to, but if they're helpful, you can watch those. All right. And then we'll go to examples. All right. Again, let me point this out. Lecture can be incredibly dry for a lot of students. So you may not get what we need to know from the lecture. Where are you going to get it? When we start doing examples. All right. Let me switch over to the whiteboard. And give me a second. All right, let's talk about it. And we'll talk about one thing at a time. And I'm going to talk about the transitive property. Okay, before I do that, I want to read this up above. It says, let A, B, C, and D be real numbers. Right. It's important that you start thinking about what's presented to you and trying to make sense out of it. All right. So I'm going to read the transitive and say, if A is less than B and B is less than C, it says it implies that A is less than C. Well, this is what's known as a transitive property. This, for most students, is going to require thinking. Here's the problem, though. I've never seen them ask that question on the exams or in the homework. It's probably the most interesting questions about inequality. It's also the most difficult one to deal with. All right, let's go to number 2. And number 2 says addition of inequalities. Well, they go on to say if A is less than B and C is less than D, then we could say A plus C is less than B plus D. Now, by the way, this also requires thinking. But again, I want to point this out. They just don't ask the question about it. All right. What they're going to focus in on is these 2 hot items over here. Whoops, sorry about that. The addition of constants and the multiplication of constants. All right. Now, the addition of constants, fairly simple. It says if A is less than B, what you can do is add C to both sides of the inequality, and it'll have no effect on inequality. I don't think that requires much thinking, by the way. If things are unequal to begin with, if you give them the same thing, they're going to remain unequal. All right. If you take the same thing from them, they're going to still remain equal. All right, let's go to the next one. If C is greater than 0, let's read this through. It's going to be tougher. If A is less than B, what they say is if you multiply both sides by C, it's still going to be that inequality, right? What do I mean by that? A is still less than B, AC or less than BC. This one over here is a bit tricky. And I want to point out what happens. If A is less than B, but if you multiply both sides by C, what happens is the direction of the inequality changes. You should notice that. This, for some students, is tricky. As we do problems, we're going to point out why it's tricky and what we need to do to prevent us getting burned with that. Okay? So I'm going to say the above properties discussed. We did do that. There's no need to memorize this stuff. Typically, when we start to work examples, the examples will be real simple examples. They're going to be linear inequality. Now, if you take Math 119, which of course up from here, you're going to see nonlinear inequality. Right? A little more difficult to do, but it's still based on this basic principle over here. In fact, the notes that we use here is the same notes we use in 119. All right. So I'm going to point out my goal over here is in isolating the variable. So let me go back to a highlighter. So when I see an inequality, my goal is to isolate the variable. I'm going to be careful in doing that though. And the only time I really need to be careful is if you multiply or divide by negative numbers. See last rule. This is the place people get tricked. We're not looking to trick you. What does it say we'll do? We'll do many examples to illustrate what needs to be done. All right, let's talk about our goal. Our goal is to solve an inequality. So what I'm going to claim over here to solve an inequality means to get the x alone on one side. Does it matter what side it's on? No. So let me look at this one over here. And I'll look at this one over here. Right? Both of those are solved for x. So once an inequality is solved, you're going to have to learn how to read it. All right, you have to learn how to read it. I'm going to claim the way to read these things is always from the variable. You're always going to read this from the variable. I'm going to point this out to you and show you what it says. This here says x is something. I'm going to read it from that. This one here says x is something. Now, if you read this one, what does it say? X is, it's opening, greater than 2. What does this one say? X is, it's opening, greater than 2. You should know these symbols, by the way. All right. So what is those? Both of those, they're both the same. Was it read as x is greater than 2? All right. X is greater than 2. They both say the same thing. All right. Now we're going to have a variety of ways of answering the question. And certainly once we solve it, in other words, we get x alone on one side, we're going to have a graphical, we'll have set builders and intervals. I'm going to look at an example. And I'll write them down for you. Whoops. How do I read that? X is greater than 2. Now, this is where I might disagree with other teachers. Other teachers they put all kinds of numbers down. I'm only interested in one number. What number? The number 2. I am going to put a circle on that. And I'll tell you why I'm putting a circle on that. I'm interested in number 2. Now, when I do when I read this thing, this is graphical. And I'll write that in the next one when I'm done with it. What is x? It's greater than 2. What does it mean to be greater than 2? To the right of it. So what we do is we say it's all the numbers over here. By the way, I can't list those numbers. So what I do is I shade it in like that. This is graphical. All right. I'm going to put down set builder. Set builder tends to be quite easy to put down. What do you put down? X, vertical bar. I want to point out what these symbols over here are. This says there's a set of numbers. X, this is read such that this condition's been met. So really what are you putting over there? The solution to the problem. Now let me talk about interval notation. This is where a lot of students get confused. And what I'd like to do is I'd like to just look at it. And when I'm looking at it, I want to put on what I'm looking at. I'm looking at the graph. If I look at the graph, I'm looking at left to right. That's all I'm doing. And where does it start? It seems to be starting at the number 2. I'll write that down. Now, someone says, what's the next number? There's no such thing as the next number. All I can say is 2, and then it goes somewhere. Where does it go? It keeps going and going and going, but never stops. Over here, if it never stops, we say it's going towards infinity. Whoops. Did it again. So this symbol over here is infinity. All right. Now here comes our conventions. Some people don't like them, but there are conventions. Our conventions are sides. There's a left side and a right side. So I'm going to say our conventions are going to be these over here. A left parentheses, right parentheses. A left square bracket, a right square bracket. These say don't touch. These say touch. Don't touch means don't include. This one means include. This is read as open. This is read as closed. Let's go back over here. I'm going to point it out to you. This is an open circle. We are not touching 2. We must be greater than 2. We're never equal to 2. We're greater than 2. It's on the left. So what symbol do we use? A left parentheses. Infinity is on the right. And I want to communicate this to you. You could never touch an infinity. And why is that? It just doesn't. It's untouchable. It keeps going and going and going. You'll never reach there. It's on the right. It's still open. We're never going to touch it. So this is the graph. That's graphical. This is set builder. This is interval. And we're another example down for you. Push this one up. And we'll write this one over here. X is less than or equal to -1. I can read that. X is less than or equal to -1. I put a line down. I only put one number down, -1. I put a circle on it. I want to tell you what my conventions are. This is the graphical approach. This is a graph. X could be equal to -1, so we're going to shade that in. In other words, it could touch it. Now, what else is it? X is less than that number. What does it mean? It's over here. All right, let's put set builder down. What do we put down? Squiggly brace, X, vertical bar. This is read as a set X such that X is less than or equal to -1. Fairly simple. Intervals, I'm looking at it. I want to point out left to right. Where's this thing going? Minus infinity. Comma. Where does it stop? At -1. This is on the left. This is on the right. All right. So if we're on the left, you could never touch minus infinity. So it's a left parentheses. -1 is on the right. So it's a right square bracket like this. This is what's known as interval notation. Hope I misspelled. Yes, we'll do other examples. All right, put one more down. Number line goes down. There are now two numbers I'm interested in. They must go down in proper order. -3, and there's a 2 here. All right. I'm going to read this to you. I want to point out this is what's called a double inequality or compound. The reason it's compound is we use the word and to read it. Let's read it. What is x? And I'm reading it to you. X is greater than this number. Now, what does that mean? It means it's to the right of it. And x is less than that number. Now, to be greater than this number and less than that number means it's between. I'm going to shade that in for you. All right, everything gets shaded in, but it could also be equal to 2. This is a graph. And again, we'll go through other examples. I'm going to put down set builder. Left to right starts at -3, stops at 2. -3 is on the left. I'm not touching. 2 is on the right. I'm touching. I'm sorry. I put down intervals. I'm spacing out. I'm sorry about that. Let me just erase that. I said set builder. I was putting intervals down. Sorry about that. So set builder to set x such that just put the solution down. That's all you have to do. Now let's put down intervals. What does it start? -3. What does it stop? 2. -3 is on the left. It doesn't touch it. Left parentheses. That's an open. And 2 is on the right. It's square bracket, right square bracket. It's closed. All right. Intervals. All right. So what we're going to do now, I get be honest with you, it's tough. I realize that. We'll go through the examples. All right. So what did we just do now? We did this. We did this. And we did this. Now we got to do the examples. All right. Thank you.